So in this lesson, I'll be teaching you guys about sets. I'll teach you everything that you need to know about sets to be able to solve any question that they might bring on the exam, tutorial sheet, or even past papers. I'll also expose you to some of the questions that they like bringing on the tests in the exams. So first I'll begin by explaining the basics, and then afterwards I'll now touch De Morgan's laws. I'll also show you how to prove De Morgan's laws. Then in another video, I'll also show you how to simplify by applying De Morgan's laws. Okay, so basically, sets are just a set is just a collection of elements. It's a collection of elements. For instance, I'm pretty sure you remember in high school they taught you about the Venn diagram, one of the ways to represent the sets. Let's say we have a Venn diagram. So imagine we have two sets. Okay, so imagine this is set A and this is set B. Okay, let's say this set has got 1 and 2, and this other set has got 3 and 4, and then here between there is let's say maybe 5. Okay, so now this is a Venn diagram representing two sets. So now when you're representing the set, the letter should be capitalized, and the elements are what the set contains. So the elements should be written in small letters. So probably let me give you an example. If we had maybe a member which is a letter like A, it would have been a small letter. Okay, so now there are two ways of representing a set. Most of the lecturers won't teach you this, including some tutors, but I'll teach you because you'll be seeing these in the questions, in the past papers, even the tutorial sheet. So I'll teach you two ways of representing a set. So in our example here, let's say set B. So let's say we have set B. So set B can be represented in this way, using what we call, these are called traces or curly brackets. So these are called traces or curly brackets. So you can represent this set using in this format, and this format is called roster. So this is roster notation. Okay, so you can represent this set in roster notation by showing the members. Let's say, like set B, we have 5, 3, and 4. So you can just write like this: 5, 3, 4. And when you're representing the elements in this notation, the arrangement doesn't matter. This can come first or this can come first, as long as you have showed the members of the set. And suppose maybe we had another, let's say we had another 3. We had 2 3s in this set. You don't need to write the 2 of them. You just need to write 1 3. You don't need to repeat the same values or the same members. Okay, so this is one of the format. And then another example, let's say A. You can also represent it in the same way. A, we have 1, A, 2, and 5. wrap them in the traces or the curly brackets. Okay, so the next notation is called the set builder notation. The set builder notation. Set builder notation. So now, when you are representing a set using set builder notation, let's say notation, when you are representing a set using the set builder notation, let's say for instance, let's say we have a set that is in roster notation, let's say A, which is a set of natural numbers. You know that natural numbers start from one going up, right? They're simply counting numbers. Let's say we have 1, 2, 3, 4. So now, in order for you to represent this set in set builder notation form, you need to do this. You need to write the trace, the curly bracket, because they also should be wrapped in the curly bracket. So when you are representing the elements, using this set builder notation, you simply describe the kind of elements that you are presenting. You giving the description of the element. So now, how do we describe the elements that we have here? So first, you have to show you are going to use a value, any value, but let's just use x since it's the most used value. Let's say x. So x is representing every element of this set, element of this set. Then you are going to put the full colon. Then now you are going to describe what kind of numbers. Okay, let me just put 3 dots. I mean, it's going to the infinity. Yeah. So now, what type of numbers do you have? What kind of a set is this? What kind of numbers is it having? What kind of elements is it having? Is what you describe A. So in our scenario, this set is having natural numbers. So you're going to say for each member or element of this set, that element is a natural number. So you're going to say that element is a member. This E represents meaning that a set is a member of a certain group or a certain collection. So we're going to say for every element of this set, it is a member of natural numbers. Natural numbers are represented by letter N. So we're going to write N. Then you have represented the set. Okay. So this can also be written in this like this. If you want A, you can simply use a straight line and also describe now the kind of element that each member is. Okay, now we write the description. We're going to say it is a member of natural numbers, like this. Okay, so now you can describe this further by let's say maybe we have a set like let me use this time letter B. Let's say we have a set like 2, 2, 3, 4. Okay, so in order for us to represent this set that is in roster notation into set builder notation, since it is starting from 2 to 4, we can add a condition to our set builder notation. So this can be represented like this. It can be represented like this. You're going to say for every element of this set B, each element, of course, they are still members of natural numbers. So we are going to say they are members of natural numbers, they are elements of natural numbers, either way. And then now we are going to, you are now going to put a comma here. You're going to put a comma, then you put a condition. What's the condition? They are between 1 and 5, right? So you can say that, you can say 1 less than, you can say 1 less than, that is each value. This x, small letter x, is representing the value of the element or the member of the set. So each element, it is between 1 less than 5, meaning it is between 1 and 5. You even close it with another trace or a curly bracket. Okay, so this is how they are represented. So now there will be some scenarios, especially when you look at interval notation. You'll be dealing with they'll give you a question in this format, in set builder notation. So sometimes they might not put they might not include this part. They might not include this part. They might just tell you that instead of they cannot include, I mean, they don't sometimes include this part. Let's say they are telling you that for instance, a set can also be represented like this. Let's say maybe set C, it can also be represented like this, x being a member of n natural numbers, and also put just a condition, because natural numbers start from maybe start from 1 going ahead, right? So maybe they can just tell you, maybe they might just put a condition that each value, each member, it is greater than, maybe let's say 2. It is greater than 2, which means that it is starting from 3 going above, right? So meaning the set is looking like this, meaning it is starting from 3. If there was equal here, it would have started from 2. So meaning it is starting from 3, 4, 5, and so on to the infinity. Sometimes it can also be written like this. Yeah, so maybe sometimes it can't be a natural number, maybe it can be a real number. Real numbers are represented by R, real numbers, N, natural numbers, and Z, letter Z, integers, and then Q represent rational numbers. You need to know this. And then complex numbers are represented by letter C. You need to take note of this so that you don't get confused. So lastly, sometimes they might not represent this part, the condition about the value, or maybe this part, they might not represent it like this. We can simply just write the statement like for instance A, instead of saying that x is a member of n, they can just write the statement that x is a natural number, and also it is between 1 and 5. I'm pretty sure if you've gone through the tutorial sheet, you'll find some questions which have been phrased like that. I hope now they will make sense. So now let's move forward. So there are some other basics that you need to understand. For instance, you need to know what a universal set is. A universal set is simply a set that contains all the elements that are under considerations, that are under observation. Like here in our scenario, a universal set is this one here, this one that is out here, because it contains all the elements that are under observation, that we are observing in this rectangular box that I've drawn. So it contains like everything. Okay, and it can be represented by E or by U. They are one and the same. Let's also talk about subset. So let's say we have maybe two sets. We have set A and B, when they say that this set is a subset of this, for instance, when they say okay, when they say a subset, they mean that that set is contained into another set. When they say, for instance, when they say A is a subset, it is represented by this sign, and B. So they're simply saying that every element of A is contained in B. This can be represented like this, maybe in a Venn diagram. It can be represented like this. So let's say this is set B and this is set A. Okay, this is set A and this is set B, and a universal set. So meaning that set A is contained in set B, meaning that every element of A is also found in B. And this is called a proper subset. Why is it called a proper subset? Because it is every element of A that is in B and not every element of B that is in A. Hope that makes sense. So if all the elements that are in A are also in B, and also the elements that are in B are also in A, that is called an improper subset, and it can be represented like this. For it, we include the equality symbol, this one, meaning that they have an equal elements. The elements that are in B are equal to the elements that are in A, and the elements that are in A are equal to the elements that are in B, meaning that they are improper subsets. They are also what are called complement sets. So let's say we have a set like set A. When we say that complement of set A, a complement is simply, it represents the elements that are not found in that set, but they are there in the in the universal set. For instance, let's say we have a Venn diagram. Okay, so maybe let's say we have set A. Let's say this is set A. When we say the complement of set A, the complement of set A is simply the elements that are not that are inside, but that are not, they are not in set A, and it is represented by, it can be represented by this sign, by just putting a straight line above there, or by showing this, symbol, the complement symbol. Okay, but oftenly you figure out that this format is usually used, and that's the one that we'll be using. And then lastly, there are some operations that can be done on a set. There are some operations that can be done on a set or on sets. For instance, let's say we have two sets, set A and B. We can perform two kinds of operations, which includes uniting the sets or intersecting the sets. When you're told to find the intersection of the set, it means that you have to assume that the sets are intersected. You have to find the elements that are found in both sets. For instance, let's say we have let's say this is set A, and this is set B. Okay, so now when you have been asked to find the intersection of the set, which is represented by this n between B, meaning they want you to find the element that are found between A and B. So you have to find, meaning that they are looking for elements that are A. Hope that makes sense. I'm pretty sure you learned that. And also, when you are asked to find the union of a set, meaning they want you now to like combine these two sets, which is represented like this, using the U sign, the U symbol, meaning they want you to find the union, meaning you have to assume that they are united. Okay, so let's say if we had like 1, 2A and 3A, 3A at the middle. Okay, I hope you can see it. Yeah, so if you are taught to find the union of this set, you have to unite them, meaning you are going to combine all the elements, meaning you're going to say it is having 1, 2 and 3. Okay, and if you're taught to find the intersection of these two sets, meaning you have to only consider what is there between. Okay, so meaning that it's going to be 3, a set having only one element. So sometimes maybe you've been in a scenario where maybe they give you like let's say a intersection of B complement, meaning that you are going to assume, they want you just to consider this one. Now they want you to list the elements that are not found in the intersection which is A, meaning they want you to only consider the elements that are in this part and in this part. Okay, so meaning that we're going to have 1 and 2, especially when we start interval notation. You'll be seeing most of these, and also maybe you might given the complement of this whole thing. Let's say maybe A union B complement, meaning that they want you to list a set, or they want you to consider the elements that are not in the union of A and B, meaning that are outside A, which is going to be a universal set, right? Okay, so this is it for now. For this video, it's just for the introduction, like the basic introduction. I don't want to make the video too long. In the next video, I'll explain now about De Morgan's laws and how to prove De Morgan's laws. That is it for this video. Ensure that you watch the next video. Now in the coming videos or the coming lessons, we'll be referring to these basic concepts, so you need to make sure that you have understood all these basic concepts. Okay, see you in the next video.